12,000 years ago, at the end of the last ice age, a continent disappeared from prehistoric Europe. The evidence has been sitting in fishing nets the entire time. For more than a century, commercial fishermen working the North Sea have hauled the same disturbing cargo up from the ocean floor. Carved bone harpoons, flint blades shaped by human hands, the molars of mammoths fossilized in the dark mud at the bottom of the sea, antlers worked into spear points, net after net of objects that have no business being where they were found, pulled from depths that should contain only shipwrecks and the bones of marine life. Remnants of sunken ships. They are too old, too primitive, and they keep appearing in places where land shouldn't exist. For most of the 20th century, the artifacts were treated as curiosities. Local museums in England, Denmark, and the Netherlands stored them in drawers. Archaeologists assumed they were one-offs, the strange leavings of ancient hunters who had wandered too far out onto the winter ice. A glove dropped on a frozen lake, a spear lost during a long-distance crossing. Nothing more. They were wrong. Modern marine seismic scanning has finally revealed what those objects actually are. They are not isolated finds. They are the wreckage of a continent, a massive prehistoric landmass that once filled the entire basin of the North Sea, connected Britain directly to mainland Europe, and stretched from the coast of what is now Denmark to the cliffs of what is now Yorkshire. The fishermen have not been pulling up shipwreck debris. They have been pulling up the surface of a country. That country has a name: Doggerland. Its highest ground, the ridge that survived the longest before finally going under, is still visible today as a shallow shoal sitting just 13 to 15 meters beneath the surface of the North Sea. Fishermen still trawl directly over it. It is called Dogger Bank, and it is the last physical remnant of the continent beneath their hulls. And the deeper investigators looked, the more disturbing the story became. Because Doggerland did not erode away. It did not slowly slip beneath the waves over thousands of years. It was killed. And until the last 18 months, no one fully understood how. For decades, the academic consensus held Doggerland in low regard. It was acknowledged as real, but written off as marginal, an icy, marshy, half-frozen wasteland that humans crossed only when they had to, but that no civilization would ever choose to call home. The textbooks framed it as a corridor between two real places, a no-man's land on the way to somewhere else. That picture was wrong too. In March of this year, a research team led by Robin Alibi at the University of Warwick published a study in the Proceedings of the National Academy of Sciences that overturned the entire model. Using a technique called sedimentary ancient DNA, SEDA DNA, the team analyzed deep marine sediment cores pulled from the bed of the North Sea. The technique works by isolating fragments of genetic material that drifted into the mud while the surface was still alive. Plant pollen, animal scat, decaying tissue. All of it carried trace DNA. All of it settled into layers that were sealed away from oxygen the moment the sea came in. 12,000 years later, those layers are intact. The genetic material is still readable. The drowned ecosystem can be reconstructed almost cell by cell. What the team found was nothing like the textbook version. Doggerland was not a frozen wasteland. It was a temperate paradise. Dense oak forests, hazel groves heavy with nuts in the autumn, a landscape laced with rivers and freshwater lakes, abundant with deer, wild horses, fish, and waterfowl. By every ecological measure the new analysis can offer, it was one of the most productive landscapes in the entire post-Ice Age world. The kind of place a hunter-gatherer culture would not just pass through. It was the kind of place they would settle. And they did. The harpoons in the fishermen's nets are not the stray artifacts of a winter crossing. They are the leftover tools of a population. The exact size of that population is still being worked out. The number of generations that lived there is still under investigation. But the evidence is now unambiguous that Doggerland was a major center of prehistoric European life. Possibly the single most desirable real estate in the world at the moment human beings stopped being purely nomadic. It was a homeland, and then it ended. The mechanism of the drowning has been understood in broad terms for a long time. The end of the last ice age released staggering volumes of water back into the world's oceans. Glacial ice sheets, some of them more than 2 miles thick, covering most of North America and Northern Europe, began to retreat. As they retreated, the seas rose. But scientists have known for decades that the rise was not a steady, gradual climb. There were pulses, sudden, violent surges where ocean levels jumped by tens of feet within a few generations. The largest of these is called Meltwater Pulse, 1A. It began roughly 14,500 years ago during the warming period known as the Bölling-Allerud Interstadial, and within a span of less than 500 years, it raised global sea levels by somewhere between 50 and 65 feet. 50 to 65 feet, vertically, in 5 centuries. That number is abstract until you put a human scale on it. For the people standing on the shore of Doggerland, the ocean was rising at a measurable rate every single year. In the worst stretches of the pulse, it climbed by 60 millimeters in 12 months, nearly 2.5 inches. That does not sound like much, until you understand that Doggerland was flat. The interior of the continent had almost no relief. On a landscape that gentle, a vertical rise of 1 inch can translate into hundreds of feet of horizontal coastline lost. Every year, for generations. Hunting grounds where a grandfather had stalked deer would be open ocean by the time his grandson came of age. The forests retreated inland. The freshwater lakes turned brackish, then salt, then disappeared entirely. Villages on the western edge of Doggerland would have been abandoned within a single human lifetime, the survivors moving east and north toward higher ground that was itself disappearing behind them. The people did not lose their homeland in a flash. They watched it be eaten, slowly enough to know exactly what was happening, fast enough that nothing they did mattered. The pulse was followed by the Younger Dryas, a sudden cold snap, roughly 12,900 to 11,700 years ago, that briefly halted the warming and gave the remaining high ground a temporary reprieve. But it was exactly that, temporary. When the warming resumed, the waters came back with renewed force. And around 8,200 years ago, a final abrupt climate event, now catalogued as the 8.2 kiloyear event, delivered one of the last major shocks to the surviving remnants of Doggerland. By that point, what little remained above water was already a shadow of the original continent. But the deeper question has stayed open for more than a century. What triggered the pulse in the first place? This is where the investigation gets strange. A small, localized event at one pole should not be capable of drowning a continent on the other side of the planet. Ice sheets are massive. Ocean currents are stable on geological timescales. The systems that govern global sea level are not, in principle, supposed to fail all at once. And yet, that is exactly what Meltwater Pulse 1A appears to have been. Not a gradual climb, a planetary failure. In February of last year, a research group at Brown University published a study in Nature Geoscience that may have finally solved the mechanism, using a new spatio-temporal modeling approach, essentially the ability to track precisely where and when each portion of ice was lost instead of just measuring the total. They reconstructed the actual sequence of events leading up to the pulse. What they found is something they call a global cascade of ice loss. The cascade begins small, a relatively minor melt on the southern edge of the Laurentide ice sheet, the enormous glacier that covered most of what is now Canada and the upper United States. A modest amount of fresh, cold water enters the North Atlantic. By any reasonable accounting, that local event should be unremarkable. Local melts happen. Glaciers shed ice every spring. None of it should be capable of drowning Europe. But the ocean is not a passive system. The water released by the Laurentide landed in exactly the wrong place, directly in the corridor of the North Atlantic currents that move heat and salt around the planet. The freshwater injection destabilized those currents almost immediately. Think of it like a giant finger pressing down on a foam mattress. The weight is the ice. The mattress is the planet. Pull the finger off one corner, and you do not just get a localized bounce. The pressure shifts across the entire mattress at once. The Brown study suggests something very similar happened to the ocean and the ice. Once the Laurentide started shedding, the destabilized currents began transmitting energy across the entire ocean system in real time. Within a window that is geologically instantaneous, measured in decades, not centuries, the massive Eurasian ice sheet and the West Antarctic ice shelves began to collapse simultaneously. This is the global cascade, a single point of failure propagated planet-wide in a chain reaction that drowned coastlines on every continent at the same moment. Doggerland did not die in isolation. It died at the same moment the floodplains of Southeast Asia drowned, the same moment the shorelines of the Persian Gulf were submerged, the same moment dozens of low-lying landmasses around the equator, the prehistoric subcontinent of Sunderland chief among them, were swallowed by the sea. For the first time, the science explains why every culture on Earth seems to remember the same disaster. Hundreds of cultures, separated by oceans and millennia, and the entire span of the human language tree, share an identical core memory: a great flood, a drowning of the world, a handful of survivors carrying what they could to higher ground. The story shows up in the Mesopotamian epic of Gilgamesh, in the flood narrative of the Hebrew Bible, in the Hindu account of Manu and the divine fish, in the oral traditions of Pacific Islanders, in the legends of Native American nations on both sides of the Mississippi, in the myths of West Africa, in the Dreamtime narratives of Aboriginal Australians. Mainstream archaeology has historically dismissed the convergence as coincidence, the natural human tendency to mythologize local floods into cosmic events. The new evidence makes that dismissal much harder to sustain. When the cascade fired, the people on Doggerland were not the only ones watching their homeland drown. The Sunderland populations in what is now Indonesia were doing exactly the same thing. So were the inhabitants of the now submerged coastal plains of the Persian Gulf, the lost shorelines of the South China Sea, the drowned river deltas of West Africa. These were not local floods, separated by geography and time, eventually pulled together into a single story by a kind of cultural game of telephone. They were a single planetary event, witnessed in real time by every coastal human population alive at that moment. What they remembered, they passed down. What they passed down, they encoded. And what they encoded survived 12,000 years of language drift, civilizational collapse, and the rise and fall of every empire that came after them, until it ended up on stone tablets and in sacred texts and in the bedtime stories of 100 different peoples who had no contact with each other. The flood myths are not coincidence. They are testimony. This is what the artifacts in the fishermen's nets actually mean. They are not curiosities. They are the physical trace of one of the largest and most traumatic events in the history of the human species. A planetary cascade that wiped a continent off the map, displaced an entire prehistoric civilization, and seared itself so deeply into collective memory that we are still telling the story today. And the most unsettling piece of the investigation is the one that remains open. The cascade model explains the mechanism. It does not explain the trigger. Something destabilized the Laurentide enough to start the chain reaction. The leading candidates split between two very different explanations. The first is an internal climate threshold finally breaking, a slow tipping point that simply ran out of margin, the way a wire under tension eventually snaps without warning. The second is an external shock, something hitting the ice sheet from outside the system entirely, a cosmic impact of the kind this channel has been documenting from the beginning. The investigation is still open on that point, but every additional layer of evidence pulled out of the North Sea, Every new sediment core analyzed for ancient DNA by teams like the Europe's Lost Frontiers project. Every refinement of the Cascade model narrows the suspect list. For now, the artifacts keep coming up. Bone and flint and ivory, dredged from a continent no living person has ever seen, hauled from the floor of an ocean that should not exist where it sits. The fishermen who pull them aboard rarely know what they are holding. Most of the museum drawers they end up in remain closed. But the picture, finally, is clear. There was a paradise where the North Sea now lies. It was home to a people, and it was killed in a planetary cascade so violent that the memory survived everything else those people ever built. The story did not begin with us. It will not end with us either. The Luster Archive will keep documenting the gaps,